All right, so today we're going to look at how we solve exponential equations. And so we're going to start by taking a look at two very similar equations. And I want you to notice the subtle difference in how we solve these. This first equation, if you notice, we are able to rewrite both sides of that equation using the same base. And so that is the process that we are going to use here. So we're going to think of this as 3 to the x is equal to 3 squared. And so remember, our property tells us that if we can rewrite using the exponents and we have the same base, then we can set the exponents equal to each other and we can solve. So we get that x is equal to 2. So that is assuming we can have that same base. Now, here's the issue. If you notice on this next example here, we cannot rewrite 11 as a power of 3. So we're going to have some other type of process that we can use. And so I want you to think about the fact that we are using inverse operations in order to solve most equations, and so that's the process that we're going to do. So I need you to think about the fact that the inverse operation of something that is exponential will be something that is logarithmic. So in order to solve this, we are going to take the log of both sides. So let's do that. So I want you to think about that process. I want you to think about the fact that if we do take the log of both sides, we would have the log of 3 to the x is equal to the log of 11. And then we know by our properties, here's the beauty of this, and this is part of the reason why we take the log of both sides. The x that we are trying to solve for at this point right now is in the numerator, is the exponent. And we need the x that we're trying to solve for. We know how to solve for x if it's in the numerator, if it's kind of in that regular place that we're used to looking at. And it's as an exponent right now. But the properties that we know, the properties about logarithms tell us we can take, if we take the log of both sides, now we can drop that x out in front. And we know that then we would have that x times the log of 3 is equal to the log of 11. Now we're trying to solve for x, and x is getting multiplied by this log of 3, and so we're going to have to divide by the log of 3 on both sides in order to solve. So it's possible that the directions will say leave as an exact answer, and if that's the case, then you would say that x is equal to the log of 11 divided by the log of 3. It's also possible that they will ask you to plug in and solve for that and find a answer in rounded form. So we'll look at some examples of that. For now, I want to kind of focus our attention on this. So this would be considered our exact answer. Another piece of information. So please be conscious and careful. We've just been working with some examples where we were rewriting using properties, and we had the log of these lengthy expressions, and we were rewriting those. So there is a subtle difference here. Please notice that we have a log in the numerator and in the denominator. So we are taking the log of 11 and then we are dividing it separately by this log of 3. So the notation is a little bit different. The tendency is for people, if they're going to make mistakes, the tendency is to want to try to combine those together and say that that should be the log of 11 over 3. And it is not. So please, 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 please be very careful with that. Okay? All right, onward. Let's look at some examples. We're not going to do a whole bunch. We're just going to work through a few of these here, and then you're going to get some practice in on a worksheet. So solve each exponential equation. On these, it says give exact answers and round to the nearest hundredth. So we will look at the decimal form of this besides the the exact answer. So if you notice, the first thing to look for is to see, can we rewrite the right-hand side using a power of 3? And we cannot. We can't write 3 to some power to get to 7. So we know we're going to have to use this other technique. So remember, we say that we are going to take the log of both sides. Now I'm going to skip a step here, and I'm not going to write this out. I'm actually just going to write in here and sneak in a little log on both sides. And then that tells us, if we have the log, then that tells us we have x times the log of 3. Another huge mistake that people tend to make is that they forget to write this log of 7 over here on the right-hand side. They forget the log. So please be careful with that as well. So now if you notice, we've got x times the log of 3. And so in order to solve, we are going to divide by the log of 3 on both sides. So our final exact answer is that x is equal to the log of 7 over the log of 3. But I want you to come up with the approximate answer also. So be careful plugging into your calculator. Make sure you're plugging in carefully. That should give you as an answer 1.77. And that's a little bit messy, sorry. All right, let's look at some other examples here. On this one as well, if you notice, cannot rewrite using 2 to a power. So we are going to take the log of both sides. And then we're going to drop that 3x right out in front. So we get 3x times the log of 2 is equal to the log of 172. So I'm going to do this actually in 2 steps. We're gonna think about dividing by this log 2 first. And then think about the fact that that leaves us with 3x is equal to log of 172 divided by the log of 2. Now we've got to multiply. We either need to think of this as dividing by 3, or remember the other way of doing that is thinking about that as multiplying by its reciprocal or multiplying by 1/3. Ultimately, what it means is that we can either think of this as there's a 3 down here in this denominator. The other way this could be written, and especially depending on how you're plugging into your calculator, it might be easier to think of this as just finding the log of 172 divided by the log of 2, and then dividing that whole answer by 3. So x is equal to this log of 172 divided by, like I said, we could write it as 3 times the log of 2. The other way we could write that is the way I have it written right up above, and that is log of 172 divided by log 2. I'm going to change colors for that just to kind of keep that consistent, divided by 3. Now if we go back and look at what the final answer is as a decimal, the approximate answer I should say, we get 2.48. If you notice now for this next example, similar process, we cannot raise both sides to a similar power, and so we are going to take the log of both sides. And when we do that, when we rewrite, we've got y minus 2 times the log of 12, and that is going to be equal to the log of 20. So notice we've got a couple of steps again that we're going to go through in order to solve here. So let's divide through by this log of 12. And then we're left with, we still have y minus 2 is equal to this. So we have log of 20 over this log of 12. And then we're just going to have to add this 2 over to the other side. So make sure you're careful plugging in here when you solve this, because we want to find what the log of 20 divided by the log of 12 is. And then at the end, you add that too. So be careful how you're plugging in there. So we find that as our exact answer. And that gives us, excuse me, let's make this a little squiggly. So that is approximately equal to 3.21. All right. Now I need you to notice these first few examples. We had a base that was just a single number. But these last three examples, if you notice, the base is E. So I want you to think about the fact that instead of taking the log of both sides, we know that log base E is the same thing as ln. So instead of taking the log of both sides, we are going to take the ln of both sides. Now this next example in particular, we want to be careful. We want to notice that there's a few extra little things that are going on first. Like, in other words, I'm going to kind of highlight. On all of these other examples, if you notice, we've got just the base by itself before we take the log. But on this particular example, we've got that 7 that's getting multiplied, and we've got this 2.5 that's getting added. So we have to think order of operations in the order in which we are going to do this solving. We need to be careful. We've got to clean up and get rid of all of that extra stuff first before you actually take the ln of both sides. So in other words, we're going to subtract this 2.5 first, and that gives us 7. That leaves us with 7 times e to the 2x is equal to 17.5. And then we need to divide both sides by this 7. So we get e to the 2x is equal to 2.5. And now we can take where we have e raised to a power. So because of the base is different, because the base is an e, not just a single number, we are going to take the ln of both sides. It's going to make the work easier because of that base. So the next step, we know using our properties that 2x drops into numerator land. So we get 2x times the ln of e. And that right there is why we do this, because this right here is really pretty. We know that the ln of e is just equal to 1. And so that's going to clean up nicely. All right, and then we are equal to the ln of 2.5. So the beauty of this is that taking the ln of e, we know this is just equal to 1. And if you are not sure of that, then plug that into your calculator to verify that and make sure in your mind that you're clear that that's okay. That basically that just becomes a value of 1, and we don't even really have to worry about it anymore. So what we find then is that x, I'm going to scoot over here a little bit. We divide both sides by 2, so we get that x is equal to, x times 1 is just x. So x is equal to this ln of 25 divided by 2. I'm sorry, 2.5 divided by 2. So that's our exact answer. And then our approximate answer is that we get 0.46. So we've got a little bit more involved in our numerator, in our exponent, excuse me, so that when we drop that down, there's a little bit more we're going to have to do. So let's take a look. All right, we've got, you have e to a power, so we know we want to take the ln of both sides. And when we do that, this 2x plus 1 drops down. And we get this ln of e, and that's equal to the ln of 8. So we know the ln of E is just equal to 1. And if we multiply by 1, then we know we are just left with, on the left-hand side, we have 2x plus 1, and that's equal to the ln of 8. And then we're going to do the steps in order. Make sure we're following the right order. We're going to have to subtract 1 from both sides. And then we're going to have 2x is equal to the ln of 8 minus 1. And now we're going to divide both sides by 2. And so we find for our final answer, our exact answer, x is equal to the ln of 8 minus 1, and all of that is divided by 2. Please be careful plugging into your calculator. I would plug this in as steps. If not, then just be really careful on your graph, on your TI Inspire. Make sure you're using that division key so that you have the fraction bar. Be careful with that. All right, you should get when you plug in, so check and make sure x is approximately equal to 0.54. I'm going to skip this one because it's pretty much this. It's very similar to number 5. So let's just look at this last one. This is not that much different either. It's just that we've got an exponent that's a little bit different. So I want you to notice that. So on this last example, we know we have to clear away anything else that's going on first. So we're going to take care of this 7.2. So we get that this is equal to 1.9. And now we are going to take the ln of both sides. And when we do that, we have got 2x over 5 times the ln of E is equal to the ln of 1.9. We know that the ln of E is just equal to 1. So that leaves us with 2x over 5 is equal to ln of 1.9. All right, last step. And you can do this in 2 parts or you can do this all together. For me personally, I'm okay with doing this all together in 1 step. If you feel like you want to multiply by 5 and then divide by 2 separately, you can. Or you can just think of this as multiplying by that reciprocal, which is 5 over 2. So either way you think about that, x is equal to 5 times the ln of 1.9. Please be careful writing this. It can get messy looking and then, excuse me. And then you get confused with your ln's and your 1's and that type of thing. So just be careful with how you are writing your ln. Maybe write it in cursive or write your 1's as put the little tags on them. So there's our exact answer. If we want to write the approximate decimal form, we get 1.605. All right. So the practice is a worksheet to give you a little bit of practice with this process. I will tell you some of the problems are a little bit trickier than this. We went pretty basic with the notes, but I think you'll be fine on the worksheet.